Good morning. In this class, we will learn what is full adder and we will see how a full adder functions. So, what is a full adder? A full adder is nothing but a combination of two half adders to overcome the disadvantages of half adders. In the previous class, we have seen what is a half adder, its truth table, how to reduce K-map, how to deduce the logic diagram from the K-map. So, here we will see how a full adder works based on the half adder extension. So, full adder is nothing but an extension of the half adder. We already know a half adder adds 2 bits at a time, and here a full adder is a combination of two half adders. So it will add how many bits we will see now. So let us see the block diagram of full adder. So here if you see the block diagram of full adder, it consists of 3 inputs which are designated as A, B and C. In this case A, B and C. These are the inputs. Where the outputs are sum and carry, where sum is indicated by S. These are the outputs where sum is indicated by S and carry is indicated as C out in this case. So here if you clearly see that diagram, a full adder adds 3 bits at a time in contrast to a half adder which adds 2 bits at a time. Now let us see how we can implement a full adder using 2 half adders. Now if you see this diagram, we are having 2 half adders where each half adder takes only 2 inputs in this case, where the first half adder, this is the first half adder, this is the first half adder and this is the second half adder. Okay. Now the first half adder takes input as A and B and gives an output S1 which is the output of the first adder, sum 1, and carry 1 which is the output, another output of the first half adder. These are the outputs of the first half adder. So these outputs are fed to another half adder. In this case, the second half adder takes an input as C and S1 as input. Here C is taken as an input and S1 is taken as another input to second half adder, which gives you the sum as the output. So here the entire block diagram, if you clearly see, it is taking 3 bits as input and computing the sum, which is the function of a full adder. As we have already seen, full adder takes 3 bits in the previous slide. So here it takes 3 bits as the input and gives the sum. So what about the carry? The carry of the first adder is indicated by C1 and the carry of the second adder, here in this case let it be C2, is fed to a OR gate. We already know what is the function of an OR gate. OR gate adds the given input bits and gives the output. Okay. Here whatever the carry from the C1, that is the half adder, first half adder is C1 and C2 from the second half adder are fed to the OR gate, which are added, and the output is a carry. So I think it's clear that how a full adder can be implemented using 2 half adders and what is the function of a full adder. With this video ends up here, and in the next video we will learn what is the truth table, how to draw it, what are the outputs of a full adder,